Another day, another story. Remote sensing. Introduction. Remote sensing is the process of acquiring the information about an object or area by measuring its reflected and emitted radiation from a distance without being in contact with the object. The data from remote sensing will be analyzed automatically by a computer and manually interpreted by humans before being used in a variety of fields. Definition and scope of remote sensing. Remote sensing is the science of acquiring, processing, analyzing and applying the information about the Earth's surface without actually being in contact with it. This is done by sensing and recording reflected or emitted energy. The process of collecting and interpretation information about a target without being in physical contact with the object. According to United Nations, the term remote sensing means the sensing of the Earth's surface from space by making use of the properties of the electromagnetic wave emitted, reflected or diffracted by the sensed objects, for the purpose of improving natural resource management, land use and the protection of the environment. Applications. Application in various Earth-related disciplines such as geology, surveying, hydrology, ecology, meteorology, oceanography, glaciology, etc. The local TV weather program uses cloud remote sensing to indicate storm passage. History and development of remote sensing technology. The concept of photography was developed by Greek mathematician Aristotle by using a pinhole camera in the 4th and 5th centuries. Photography was originally invented in the early 1800s. The world's first chemical photograph was taken in 1826 by Joseph Niepce of France using a process known as heliography. The word photograph was coined in 1839 by Sir John Herschel and is based on the Greek meaning, drawing, writing, together meaning, drawing with light. Evolution of satellite remote sensing in India. Following are the historical developments in remote sensing technology in India. Following the successful demonstration missions of ISRO's experimental Earth observation satellites Bhaskara 1 and Bhaskara 2, which were launched in 1979 and 1981, respectively. India began work on an indigenous IRAS, Indian Remote Sensing Satellite, program. IRAS is an integrated LEO, low Earth orbit, component of India's NNRMS, National Natural Resources Management System, with the purpose of establishing a long-term space-borne operational capability for natural resource observation and management in India. India recognized early on that the long-term viability of its space program would be contingent on its own technological skills. In particular, US export restrictions made this clear. Principles of remote sensing. Detecting and recording radiant energy reflected or emitted by objects or surface material is what detection and discriminating of objects or surface features entails. Varying things incident on the electromagnetic spectrum return different amounts of energy in different bands. This depends on the property of material, structural, chemical, and physical. Surface roughness, angle of incidence, intensity, and wavelength of radiant energy. Remote sensing is a multidisciplinary science that combines a variety of disciplines such as optics, spectroscopy, photography, computer, electronics, and telecommunications. As well as satellite launching, all of these technologies are combined to form the remote sensing system, which is a comprehensive system in it. A remote sensing process is divided into several steps, each of which is critical to its effectiveness. Components of remote sensing. 1. Source of illumination. The foremost requirement for any remote sensing process is to have an energy source which illuminates or provides electromagnetic energy to the target of interest. 2. Radiation and the atmosphere. As the energy propagates from its source to the target, it interacts with the atmosphere as it passes through. This interaction may take place a second time as the energy travels from the target and back to the sensor. 3. Interaction with the target. Once the energy makes its way to the target through the atmosphere, it interacts with the target depending on the characteristics of both the target and the radiation. 4. Recording of energy by the sensor. After the energy has been scattered or emitted from the target, a sensor is required to collect and record the electromagnetic radiation. 5. Transmission, reception, and processing. The energy recorded by the sensor has to be transmitted, often in electronic form, to a receiving and processing station where the data are processed into an image, hard copy and/or digital. 6. Interpretation and analysis. The processed image is interpreted, visually or digitally or electronically, to extract information about the target which was illuminated. 7. End users and application. The last element of the remote sensing process is achieved when the useful information is extracted from the imagery reveals some new information or assist in solving a particular problem. Electromagnetic radiation, EMR. By conveying the oscillation of the electromagnetic field over space or matter. Electromagnetic radiation acts as a carrier of electromagnetic energy. The Maxwell equations are used to calculate the transmission of electromagnetic radiation. Wave motion and particle motion are both present in electromagnetic radiation. Characteristics as wave motion. Electron magnetic radiation can be considered as a transverse wave with an electric field and a magnetic field. The two fields are located at right angles to each other. Here the wavelength, frequency and the velocity have the following relation: C equals LV. L equals is the wavelength, m. C equals the speed of light, 3 times 10 to the 8 meters per second, and V equals the frequency, cycle per second, Hz. Characteristics as particle motion. Electromagnetic radiation can be treated as a photon or a light quantum, and energy A can be expressed as A equals hv, where h is Planck's constant and v is the frequency. According to the principles of wave theory, all electromagnetic radiation has fundamental qualities and acts in predictable ways. An electric field, A, varying in magnitude in a direction perpendicular to the direction in which the radiation is traveling, plus a magnetic field, H, aligned at right angles to the electric field, make up electromagnetic radiation. Electromagnetic spectrum. The electromagnetic, M, spectrum encompasses all types of electromagnetic radiation. Radiation is defined as energy that travels and spreads out as it does so. For example, visible light from a bulb in your home and radio waves from a radio station are both examples of electromagnetic radiation. Microwaves, infrared light, and other forms of electromagnetic radiation make up the electromagnetic spectrum. Electromagnetic spectrum, the entire distribution of electromagnetic radiation according to frequency or wavelength. Although all electromagnetic waves travel at the speed of light in a vacuum, they do so at a wide range of frequencies, wavelengths, and photon energies. The electromagnetic spectrum comprises the span of all electromagnetic radiation and consists of many sub-ranges, commonly referred to as portions, such as visible light or ultraviolet radiation. Electromagnetic spectrum, the entire distribution of electromagnetic radiation according to frequency or wavelength. Although all electromagnetic waves travel at the speed of light in a vacuum, they do so at a wide range of frequencies, wavelengths, and photon energies. The electromagnetic spectrum comprises the span of all electromagnetic radiation and consists of many sub-ranges, commonly referred to as portions, such as visible light or ultraviolet radiation. The visible spectrum includes the light that our eyes and remote sensors can detect. In comparison to the remainder of the spectrum, the visible portion is quite small. There is a lot of radiation around us that our eyes can't see but that other distant sensing technologies can detect. The visible wavelengths cover a range of approximately 0.4 to 0.7 The longest visible wavelength is red and the shortest is violet. Atmospheric window. Some electromagnetic radiation passes through the atmosphere with ease, while others do not. Transmissivity refers to the ability of the atmosphere to allow radiation to travel through it, and it varies depending on the wavelength, type of radiation. The gases that constitute our atmosphere absorb some wavelengths of radiation while allowing other wavelengths to pass through. Absorption bands are the parts of the electromagnetic spectrum that are absorbed by atmospheric gases such as water vapor, carbon dioxide, and ozone. In contrast to the absorption bands, there are regions of the electromagnetic spectrum where the atmosphere is transparent to specific wavelengths, i.e., there is little or no absorption of light. Because they allow radiation to travel easily through the atmosphere to the Earth's surface, these wavelength bands are known as atmospheric windows. Most remote sensing devices on aircraft or space-based platforms operate in one or more of these windows by making their dimensions with detectors tuned to specific frequencies, wavelengths, that pass through the atmosphere. There are 4 windows in the atmospheric windows. 3 windows are present in the thermal IR region and the 1 window is present in visible and reflected region between 0.2 ohm. Due to the extreme moisture in the atmosphere, strong absorption bands can be detected at longer wavelengths. Remote sensing platforms. The platform is the vehicle that transports the instrument, or sensor. A remote sensing platform is created with a certain set of goals in mind. When developing a remote sensing technology, many crucial decisions must be made. Defining the type of sensor and its capabilities is necessary. Thanks for watching. Next lecture on list of platforms.